Hi guys. Guys, can you hear me?
Hi, bro.
Hi, hi. Hi Bharat Krishna. Hi bro. என்ன இன்னைக்கு மைக்ல வராம மெசேஜ்ல வரீங்க பரத் கிருஷ்ண ப்ரோ? Hi Rajasugam. Hi, hi. So guys, did you enjoy the last 4 days of the session? Yeah. Guys, yeah bro. Okay. ஏன்பா எல்லாரும் மெசேஜ்லயே பேசுறீங்க? மைக் ఆన్ பண்ணுங்கப்பా. Just be interactive guys. మైక్ ఆన్ చేయండి. ఏం ప్రాబ్లం లేవు.
Aha, multi-language skills. Yeah, guys, you are free. Feel to talk here. Today we are on the last day of our workshop. How excited you are? You can say about it. Any reviews means you can also share that here.
So, how did you enjoy guys? Did you find it useful the last 4 days? And are you eager for the fifth day?
Come on, bros. Open your mic and you can speak. You have a chance here. Come on, anyone.
So, Karthikeyan, since no one is opening their mic, we will call by names and they will open their mic.
Yeah, you all know that who I am going to call. Bharat Vishnu, bro, as you are the most interacted person here, you can say about the workshop, how it was. I think he
Guys,
can't be able to
no
turn on
chat,
his mic.
just mic, bro. No, bro, Karthikeyan, bro. He's waiting for his time. He said that he
Oh,
will open later.
okay, okay.
So, there is gonna be a voice reveal in this meet. So, Bharat Vishnu is going to voice reveal. So let's shall wait for that moment. So, next, Karthik, please choose somebody. Yeah, someone. Okay. Okay.
Okay.
Hi everyone, how are you? And so I am Sahajanya. I am from third year BTech CSC, and myself and Goberan Anna, we both will be taking today's session, day 5. This is the last day of our day 5-day workshop. And so, shall we start now? Okay. So I hope you guys would have had a basic idea of Python syntaxes, Python language, and then about OpenCV. So these are the basics required for our today's session, where we'll be most probably doing the codes. Has everyone installed OpenCV library package? Is there anybody who did not install? Then first I'll show how to install it and then I'll start with the coding. Okay, then first I'll share my screen and show how to install the package. And so now is my screen visible?
Yeah, Ka, yes.
Okay, then to install OpenCV, you have to search it for OpenCV installation, and then you will get pip install code. Wait a minute. Yeah, this is the one. So just enter this in your command prompt or your ideally your OpenCV Python library will be installed. As I have already installed, let me show you. So I have copied this. I'm using Visual Studio Code for running all the Python codes, and then in the terminal, I'll be just pasting it. And since I have already installed, it will be it is showing as requirement is already satisfied. And if you are installing now for the first time, then you'll be getting a lot of things. It will be installed. Okay. And today for this one, first we are going to deal with the Gaussian blur, median blur, that is some blurring effects, and then some edge reduction effects. And so now uh, we'll be starting with a code which will show how to merge the image and how to blur the image and etc. Anyone? Okay, fine, let me continue. So for importing the image, imread is the function used to import the image from the source and store it into a variable called as image. So generally, the image has RGB channels. That is, it has red, green, and blue. In case of OpenCV, it is in reverse, BGR. So then, first we are splitting the channel into BGR, that is the three different channels, and then we'll be showing them what is the blue channel, what is the green channel, what is the red channel. Blue channel means where it has more amount of blue, green channel means where it has more amount of green element, and similar for the red channel. So then we are separating into three channels, so that the image has been separated into three channels, that is the three components of the colors. And if we again merge it, what will happen? It will form the same image again, so that the merged image is similar of the given image. That is what we have given. BGR is equal to cv2.split of image. This split function will split the channels, and then we'll have this blue channel, green channel, red channel. I am sure is the function which is used to display the image. Okay, then so here B will have the blue, green, G will have the green, and R will have the red. And so now we are using the merge function, and we are giving all the three channels as the parameter, and thus it will return an image of the merged one. So then we are converting it into a grayscale. So for grayscale conversion, you have to use CVT color as the function, which will take two parameters. One is the image, and another one refers to color underscore BGR to gray. That is converting into BGR into gray. That is that parameter. So then this will return an image of a grayscale. So grayscale image is stored in this grayscale, that I am sure. And now we are blurring it. Blurring in the sense we are reducing the noise effect. And thus we are doing the Gaussian blur. So here in Gaussian blur, we will be blurring the image by using a kernel. So here, let me show you how a Gaussian blur works. So here a Gaussian blur, let us take this as the image with these pixel values. And now here, each pixel value will store each of the RGB values. And here, since it is a grayscale image, let us take that it has only one channel, and thus it has those numbers. For example, let us consider it as these numbers, and this is the image of 512 cross 512. So the kernel will be having a kernel, that is a matrix. So let us take the matrix to be 2 cross 2. So that in here what will happen is it has a matrix of 2 cross 2. So it will take the, it will first start from 0 comma 0, and it will take all the things, that is all the values which is present in those 2 comma 2 values. That is, it will take first 4 pixels like this, and then it will average it. So here 1 plus 2 plus 2 plus 3 divided by 4, we get 2. So now all the values of this is replaced with 2. That is the average of the kernel value. And next, this will go to, this will slide to the next pixel, and it will take this 2, 5, 3, 4, and then it will average it, and then it will replace with the average value, and it goes on, and then it will slide down, and then it will take these 2 rows, and so it will do like this. And for example, let us take this first 4, and the final Gaussian blur will look like this one, these 4 pixels. Can you understand, like, any doubts in this one? Anyone?
No, Akka.
Okay. Will the value of the pixel be same for each and every image or changes? No, the value is that it refers to the pixel value of what image you give. So if it is, for example, in grayscale, means it will have only one channel, and so that it depends upon, if you take a pixel, the value of that channel is the thing which you are gonna take average, so that it will differ for each one. And the kernel size is also it depends upon your wish, because here we are taking 2 cross 2. If you want, you can take 4 cross 4, 10 cross 10. It is all purely on your wish. Is it clear? Okay, fine. May I know, Charan, you have raised your hands? Okay, fine. You have installed OpenCV library, right? Like I have shown you. If you want, I show you once again already, or if are everyone completed with installing those libraries? Okay, I hope everyone have installed it, because I get responses only from few of you.
If you have not installed, means you can check the pinned comment of our Step into Robotics group. There will be the instructions, you can install from there.
Okay, I'll proceed. And then I think you have understood the Gaussian blur. So here we have taken 15 cross 15 as the kernel size. So the Gaussian blur, we are giving the image as the parameter, and then 15 comma 15 refers to the kernel size. Okay, so this will return the Gaussian blurred image. And similar to Gaussian blur is the median blur. Here also we'll be giving the image, and we'll be giving the kernel size of 15. So the difference is, here in the Gaussian blur, you can give any kernel size. It can be like square or a rectangle. No problem. But in median blur, if you give 15, then the kernel size should be 15 comma 15. Okay, then this function is the median blur function, which is used to blur the image, and then the median underscore blur will store the median blur image, which this the output of the function, which is the return value of the function. And now we are going to edge deduction. Edge deduction, and in case of median blur, it takes the median value. That is, in case of Gaussian blur, we saw that it will take the 15 cross 15. So here it is 15 cross 15, but in this example it is 2 cross 2, right? So here what it does is, it takes all the 4 value, it takes and averages it. But in case of the median blur, it will take the median value of this one and then replaces. Instead of taking average, it takes the median value. That is the major difference between the Gaussian blur and median blur. And now, edge reduction. So what is an edge? Edge is the thing that surrounds a object. That is, it surrounds the object. That is, it differentiates like two components. Let us say, in an image, it is used to differentiate the components. So now, we are using a canny edge detector. So here, let me explain what is canny edge detector. For example, it will differentiate the components. That is, it will eliminate all the unwanted details and only show us what is the required thing. That is, what is the main idea of the image. That is what the canny edge detection does. So here it takes the grayscale as the input, and we have 100 and 200 two things as the parameter. So what is that? Generally in an image, let me take an example of this image. So here, let us take, if the what is the main idea of this image? The two cars are the main idea of this image. So now here we have to differentiate this one with this one. So you generally think of it in the grayscale image, the pixel value of this one and this one will have a larger difference than any pixel here and here. And in this pixel will have a difference, large difference with this one than the pixels inside this car and pixels, 2 pixels in this car. So there will be a large difference in the pixel if it is the edge, and the components inside the pixels inside each component will have a similar edge, similar pixel difference. So that is what is given here. So we are giving that the pixel difference minimum should be 100 and maximum should be 200. Okay, and that is where the edges are being plotted. And now we are using this imshow function to display all the images which we have got. So weight key, the weight key is the function which will say how much time the image should be displayed. So here if we give 0, it will be there for infinite time. And then for destroy all windows is the function where it is used to terminate the application. Now I'll run this. You will see what is, yeah. So fine. So let us start with blue channel. So this is the blue channel of the image. This is the green channel of the image where you will see which part has more green and which part has less green. And this is the red channel and the merged image. See, the merged image of all these three channels and the original image are nearly same, because, and thus we can say that the image has only three channels, blue, green and red. And now let me go for the grayscale image. This is the grayscale image of this merged image, and the original image is this one, and this is the Gaussian blur, and then this is the median blurred image. Okay, and then finally you will have the canny edge detection. See, these are the main edges, and this is the car which we like. This is the main component of the image, and those edges are being detected, and you will have this. And this is about the blur and edge detection thing. I hope you all understand. Any doubts you have? Any doubts? You are free to ask. If you want, you can even raise your hand. Okay, fine, no doubts. Then fine. So now we'll be going into like some application oriented. Okay. So can you say any examples for these edge detection things where it is used in real time application? Can anyone say some interesting application? Anyone? So guys, you better think of that. Then I'll show you one application based and then I'll ask you. Okay, fine. So now we'll detect shapes. Okay, we'll detect what are the shapes present in an image. And now let me show you one example. So here let us take this image. And here it has two shapes. One is green and another one is red. So, sorry, one is square and another one is circle. And so that this should differentiate between the application will say as this image contains a circle and this image contains a square. That is what that is the main aim of that program. And so now we will be starting. The general thing is we'll be importing the OpenCV library. That is the general thing we'll be starting with. And then this function will, and then this program will contain two functions. One is the detect image function, and another one I'll show you, that is the get labeled image function. So what will the detect shape function do is, it will first detect all the images present, all the shapes present in the given image. It will take the image as the parameter. And then here in get labeled image, so it will take the image and the detected shapes. Detected shapes is generally the return thing from this. We'll be seeing it in the main function, and so that you'll have a clear idea. And so it will return the labeled image. What is labeled image means, now we will be writing inside the image. So that is the get labeled image function. Okay, so we'll go to main function, and then I'll explain you about what is happening inside the function. Okay, so now Python has a variable called underscore underscore name underscore underscore. It is a default variable. So what will this variable do? This variable will specify in which part of the program is the current execution going on. So if it has the value as main, then it is that the main function has been going on. If it is inside some function, it will return that function's name. Okay, so here, and now it is inside the main function. So here, generally we know that to load, we'll go into the main function. Generally, you know that in order to load a image from the path into a variable, you should have the directory path. So here we are going to deduct shapes for nearly 10 images. So the common, I have stored all this in image underscore data folder. So for all these 10 images, the common directory path is image underscore data. You need not mention the previous folder and all, because both the shape deduction and then this image and images are in same directory. So previous directory are to be ignored. So it is not needed, not required. So for the first image, directory path is a variable. If you want, you can use variable here, or you can directly you concatenate it. That is upon your wish. Just for simplifying this, we are using that. Okay. So this will have the value, and we are looping it for 10 times because we are having 10 images. I guess you had the basics of Python yesterday, so you know the syntax of what is for loop. And then, so the for loop for the iterating variable in range. So as you know that the range function will have start value and the end value, and it will take the values from 0 to 10. It will not include the 11. So the file underscore number will start from 1 to 10. So now we are constructing the file path. So in previous thing, we did not construct the file path. We just directly gave it because it was only for one image. And now we are doing this because we are testing it for like 10 images. If it is for one image, then you did not do this work. You can just give the direct path there itself. So now we are concatenating the different components of our image path. So now the image directory path, that is this one, the image underscore data. So that will come here, and along with you are adding the test underscore image underscore, because each image is stored like this: image underscore data underscore 1.png, 2.png, and all. So that this comes in. And where do string of file number will come? It will come for this one. The file number is the iterating variable which will have the values of 1 to 10. So that will come here, and .png, as you know that it is the extension for any image file. So this is the string concatenation in Python. In Python, string can be directly concatenated by using plus functions, and you need not use any special functions like you use in C and all. So now you are done with creating the image path, and then you are just directly reading it using imRead function. So remember, imRead is for reading the image, imShow is for displaying the image. imRead function extracts the image from the given path and then stores it into a variable called as image. And this print function is just to differentiate within each image, like first image, second image, and all. And now we'll go to detecting shapes. So for detecting the shapes in the image, we'll be calling the detect shapes. And then detect shapes will be printed, and then we'll be using the get label image to label the inside these shapes, and then it will show the image, and then comes for wait key. So here in wait key, you will be passing the number of milliseconds the image should be displayed as the parameter. So if it is 2000, it will wait for 2 seconds. Let me place it as 5000. So 5000 means it will be for 5 seconds, okay? And then destroy all windows to terminate the program. Okay, now let us dive into detect shapes functions. Okay, then in detect shapes, it will take image as the parameter. So here I have created a mutable data type of Python, that is the list, empty list of detected shapes. So now inside this, first I am converting it to grayscale image. As we saw in last time, CVT color is the function which is used to convert into grayscale, and color, the parameters are image comma BGR to gray. And then now we are coming to thresholding. So thresholding is that the grayscale image is being converted into a binary image. That is what the thresholding does. So the thresholding takes grayscale image as the parameter, and then it will convert it into a binary image. So here, if the value is between 175 to 255, that is the grayscale image channel value is between 155 to 255, it will turn into white. If it is less than that, it will turn into 0. But here, since our background of the image has been white, so if this is a darker color, so that this will have a larger value only. But if it is turned into white, and then the shape is lost, so that we should convert into black. So this thresh underscore binary underscore inversion, INV stands for inversion. Okay, this comes in place. Okay, so this is what thresholding does. So basically thresholding converts into an image from grayscale into binary, and so this variable called as thrash will have all the binary image. And now we are finding the contours. Contours is again like edges. So here for contours, we are using a function called as find contours, which will take binary image as the parameter. And then these tree and chain approximation, this specifies that where you draw the contour and how to find those contour, and that will be specified by this one. So basically these are generally constant, and then this is the binary image binary image variable. And now this contours is a list. So all the outlines are stored in this contour list, and then you have to iterate into each outline, because one image can have more than one shapes, and so that it will iterate into each outline, and then you have to find the details of the shape. Okay, so I'm creating a empty list called as shape details, and then initializing shape color cx and cy stands for the midpoint of those images. All are none initially. And now first I am detecting the shapes. So I'm using approx polydp function. Approx polydp is generally an approximation function which will give the shape details of the past contour. Okay, So now contour is the variable. This contour variable is an iterating variable, that is one single contour, that is one single outline is passed. And now here we are coming for the this one, that is the 0.04 into cv2 dot arc length of contour comma true. And what is this? This is a precision value or epsilon value. We are scaling the shapes because the the image we have can have two or more shapes with different sizes. It is not required that it should have of same size. So now we are for that is the reason why we are using that precision value. If the precision is more, then you can have good results. And it is like it is generally a rule. You can think of it as a rule that how much strict the function should work. You can take it like that. So now arc length is the function which will return the perimeter. So generally, arc length refers like perimeter of the past contour. And now we are passing this contour and true, this true and this true. It is like it says whether the image should be treated as closed image or open image or not. So that is what this parameter true returns. Okay, I guess you all are clear till now. And now we are going into how detect what shape is this. So len is the function which will return the length of the given array. And so now if the length of the list approx is 3, then it is a triangle of as of course if it is a triangle. If it is 4, then it is a rectangle or square. If it is 5, it is a pentagon. We are restricting the size till 5 here for our easier use. And then if it is if it does not goes to this anyone, we are considering to be a circle. Okay, so now if it is 3, it is a triangle. If it is 5, it is a pentagon, else it is a circle. But if it is 4, you have two choices. It is a square or rectangle. For that, we are using bounding ret function. Bounding ret function, and we are passing this approx as the parameter. So it has x, y, w, h as the return value. What is x, y, w, h? X comma y represents the x and y coordinate of the starting point of the contour. Okay, and w comma h returns the width and the height of the contour. Okay, so now of the sides, let us consider to be sides. Aspect ratio is width by height. Generally, for a perfect square, it is 1, else it is a rectangle. And we are allowing a negligible difference, like from 0.95 to 1.10, it to be square, and then else it is a rectangle. So then pentagon and circle. So we have successfully detected the image. What is the shape? And now we are detecting the midpoint. What is the midpoint? We are using moments function. See, generally, if you take in OpenCV, in many of the application, you will be using it to detect the midpoint. So in anything you use, this 4 lines is mandatory. That is, it is the basic step you can take like that. You can consider to be like syntax, for example, you take it. If you are using for midpoint, then this 4 lines are important. So this moments function, what will it return? It will return a dictionary. So this dictionary will have 3 key value pairs. 3 key pairs M00, M10, M01. M00, M10, M01. So this is how you'll be accessing the dictionary for key value pair. This is the key, and next the value associated with this is a value. Okay. So what is M00? M00 will show the overall area of the contour. M10 represents the center of gravity when it is placed in the x-axis and let this horizontally, and y-axis is M01. Okay. For this midpoint Cx and Cy, we are finding the midpoint by dividing this M10 by the total area. For y, M01 by total area, and it will return the value, and int is the function which is used to convert the given like float value or anything into the integer. And now we are done with finding midpoints also. Now we are interested in finding what color is it. And here if you see, we have been restricted ourselves for only these colors, for like 6 colors. If you want to, if you're interested in giving more colors, then you can uh, find the BGR like RGB values. If you Google it, you'll be getting all those functions or those values, and you can find based on it.
Akka, Rajasugam asked to repeat the previous thing M00, that thing.
Oh, this one, okay. And now, so here, moments is the function which will return a dictionary. Okay, so this dictionary will have 3 key value pairs. So the keys here are M00, M10, and M01. So this key will have the values corresponding to that. So what is M00? M00 is the overall area. It is the overall area. What is M10? M10 is the center of gravity when it is placed in horizontally, that is in x-axis, and M10 is the center of gravity if you place it in y-axis or vertically. Okay, so now for finding the midpoint cx, you consider it as a formula. Okay, if you generally this will be used, no other changes will be made in this code for finding the midpoints. Okay, excuse me. And for finding the midpoint in x-axis, you will be dividing the center of gravity of horizontally by total area, and vertically, that is m for y coordinate, it is like vertically by overall area. Did you understand, Rajasugam? Okay, fine. Let me proceed with that. So I am finding the color of the midpoint. So I am storing a value of BGR with the midpoint, that is image of CY and CX. This is how you will be accessing each pixels in the image. And now, since BGR, because OpenCV takes as BGR has a list of 3 values which will correspond for blue, green, and red respectively. Okay. So I am first checking what is the color. So as you all know that blue means the first, that is B will be having higher value, GR is low. Green means B and R are high, G is low. Red means red is high and BG is low. So first you'll have a list with 3 values where the first, that is indexing 0, 1, 2. 0 refers to blue, 1 refers to green, and 2 refers to red. Okay. So if it is blue, then 0 is high. Yearly, like I am giving us 256 because it will take range function, it will take from till 255. And make sure that we are only finding the image midpoint color, not the entire image color. If image has if image is of multicolor, then this will not work. This is used to only find the image midpoint. So let me explain from this. So blue BGR 0 is of higher range and remaining green and red are low. Similarly for green, see green is higher range and remaining 2 are low, negligible. That is 0 to 16 is considered as negligible. And for orange, it is a mixture of what? Green and red. So it will have a smaller amount of green, larger amount of red, and negligible amount of blue. And similarly, it is like for violet, indigo, and yellow. It is based on the color composition. And now you have seen the shape underscore details is the list, and I will be appending all the shape details like what is the shape, what is the color, what is the midpoint into it. So append is the function which is used to add an element into a list. This append function will add those element in the end of the list. Okay. So I'm appending this color, the shape, the midpoint inside the shape details, and the detected shapes is the main list, which because image can have more than 2 3 shapes. So all the thing will be appended into that main detected shapes list. So generally you think of detected shapes to be a 2D list. a list inside which list of shapes are there, and then this detected shapes is returned. And now we'll go for get labeled image function. So in get labeled image function, it is easier. As you see, we are just unpacking the packed values present in those list. Okay, so here for detected in detected shapes, so detected will act as the iterating variable, and in this detected sorry, so first thing is the color. So color will be in the 0th index, shape will be in the first index, and the midpoint will be in the second index. So I am unpacking those things, and then put text is the function which is used to write the text inside the shape, that is inside the image, and I am passing image, and I am passing the string as color comma shape. So it will take as color comma shape as the text to be written inside the image, and then where to write in the coordinates. How to write represent these font of Hershey Simplex 0.5 and 0002 are the, what is the shape of, what is the font you have to write, and what is the color of the font you have to write. 000 means it is black color. Okay, and those are those parameters, and then I am returning the image. So this is all about how this code works, and in order to show you, I'll run this code to show how well it work. Oh, sorry. And see, here you have green and red, so square and circle. And for the next image, you have different images. See here, this is small size, this is larger size. So in order to consider it as similar, I have used those arc in that thing. Okay, so now you can see this is how this works. See, here is this is the text, like shape comma color comma shape thing. And so now, so this is those list thing. Okay, this will be one list, and this will be the main list. Okay, I hope you all understood. Any doubts? Doubts are welcome. Any questions? Okay, can you all say the any application for this age reduction, that is contour reduction and all? So I'll list some of the examples where you have some Snapchat filters, some filters which will detect the edge, and in the remaining place it will show the thing. And then some other example is like in daily life example, you can say, you can take examples like airport security check, where you'll be passing your suitcase and all, and there will be deducting lines, like if it is shape similar to those armed thing in military and all, they'll use, if some shape is being directed like that, and then they can relate it as you have some arm things, or you can say shape of the gun and all. So now you'll we'll see application based thing. So now here we'll take this image. So our main aim is to find number of cars in the image. That is what our program does. Okay, let us go into the program. So now it is as you have seen a similar example before that, it will be very easier, and we can, you can easily understand it. So here you have different functions. Load image function is to load the image, like generally I am read to load the image, and if it is image is none, then there is error in loading, that is the print image which you will print. So pre-processing image, so here in this pre-process image, you are first converting it into a grayscale image, and then you are blurring it, as we saw, we saw initially today, like Gaussian blur and canny. So that I hope you are clear in that. What will it do? The blur will take the Gaussian blurred image, edges will have the all the canny edges, and you're returning the edges in this pre-process function. And then in direct contrast function, you are passing go- the edges as the parameter, and then you are finding the contours. and then filter contours. So here we are using filter contours because you can have unnecessary contours. Like here, if you see in this cast dot, sorry. So in this image, if you take, so there is possibility that it could detect this one as a contour, this one as a contour. So you have to remove all those. So how can you remove? So generally, a basic idea is this is of smaller size than the main contour in which we are interested. So for that, you are restricting the area. Okay, the area should be greater than mentioned area, like a minimum area of 80. So this is what we are using for filtered contour. This is the use of filtered contour, and now you are returning the filtered contour. So this line, this will append the contour. If this is a new syntax, which is this is what Python does, it makes the syntax simpler and easier. Okay, so it will return the contour if the contour's area size is larger than the minimum area. Okay. So this is the main idea of this line, and then the filter contour is being written. So now in countcast is the main function, and it will load the image, it will pre-process the image, it will detect the contour, it will filter the contour, and then number of cars is detected. So how the number of cars is detected? The length of the filtered contours. That is the car contours. That is what being written from the filter contour function. Okay. So now you'll have the length of the contours as number of cars present, and then you are showing the image, and then as wait key destroy all windows, as we saw previous two applications, and then here comes to count underscore contours. So we are calling this function with the address of our image, and then here the count cars will call all these inside functions. Okay, so now when I run this, you will have the image, and we have 10 cars. See here, the detected cars is 10. Okay, any doubts? Any doubts? Are you clear with this? Okay, then if you don't have any doubts, then Guber and Anna will continue the meet.
Hello guys, have you understood the concept which have been taken so far? Hello guys, anyone else? Okay, fine. So yes, we have been using OpenCV in our daily life, and these are images we downloaded it from the net. But what if there is a real application? So in the same application, if let's assume a situation. Let's say there is a criminal who's at loose, okay, and he has been taken a blue color car as a getaway vehicle, and he is going in a highway. So in highway or in some congested area, there'll be very much of a traffic, and you can't see each and every car from our viewpoint. So when we take in this point of view, we have masking. So what is a mask? So we use mask. We all have used mask during COVID times. So what does the mask do? That mask creates a gap and actually separates us and the viruses and whatever the dust which is outside. So just like that mask, this mask also separates a color which we specify. Sarjanya, can you just stop presenting?
1 minute, Anna.
Yeah, fine. Is the screen visible?
Yes, na.
Fine.
Yeah.
Okay. Yeah. So here is the code for color-based object detection. As usual, we are importing CV2, we are importing NumPy, and we are reading the image using the CV2 ImRead function. People have been told many times in these 2 days. And we are converting it into HSV image. Why we are converting into HSV image? Do you guys have any idea? Please interact more. Then only you will understand. Anyone in the chat box? Okay, fine. Let me say. So when we are converting HSV image, the hue saturation value. The saturation means, for example, let's say we are dealing with the color of red. So the hue, when the hue changes, the red color will change to pink, orange, yellow, or any other color, sometimes green. But the saturation, when the saturation changes, it will be light red or dark red. It will not change the color. So we want to care only about the color part and not about the brightness or the saturation. So which is why we are converting into HSV. In OpenCV application, whatever we do, we just have to make it easier for the computer, because unlike humans, it can't analyze much. Are you guys clear so far?
Yeah, Anna.
Okay. And then lower blue, upper blue. So which is why we have imported the np.array. This creates an array. Why we are creating an array? Because we have used lists so far. We have never used array because Python doesn't have an array. Which is why we are creating array. So lower blue is BGR. This means 100, 150, 0. This is the lowest amount of blue you will find. This is the highest amount of blue you will find. You might have a question, bro, this is a BGR image and you are calculating lower blue. Then why the blue value, that means the first index value is lower than the second index, which means the green is higher and blue is lower. Why is that? Can anyone answer the question? The answer is right there in the screen. If you just squint your eyes and look closer, you may find the answer.
Question one more time, bro.
What?
Question.
No, professor, bro, it's not the range. I will let you see the code once again. Yeah. BGR. But the blue value is 100, green value is 150. Then green dominates more and blue is less, and there is no red. So what's going on? Why blue value is lesser than green value?
Lower blue.
Okay, even if it is lower blue, both green and red should be lesser than the blue. Blue should be high. Wavelength. Yeah, wavelength is the nearest right answer for this question because we are converting into HSV. While converting into HSV, the image will look not in, I wouldn't say inverted, it would look like inverted. So in while you are seeing blue, when you remove the saturation, the hue value will look kind of like green. So when you are approaching blue, you should approach kind of like green but slightly mixed with the blue. So that's the logic behind here. Okay, let's go on to the next one. Mask. So as I said before, like COVID, we wear mask which separated us and the viruses and dust. But this mask, we have to tell what it should separate and what it should not separate. Which is the name is mask, but it acts like a filter. All right. So CV2 dot in range. That means the function speaks for itself. If the pixel range is between lower blue and upper blue in this HSV image, then it would be turned into 0. That means that part, that pixel will be taken out of the picture. And blue objects. These blue objects contain the masked out image. You will realize after I run this code and show the output. So bitwise and you all know truth table, right?
Yes, bro.
Can anyone unmute and say what will the and function do and logic?
And if both inputs are 1, then it will show 1, else 0.
Perfect. So that's what we've been doing here. So we are converting both the original image and the HSV image, and if in original image all the pixels are present, we haven't masked out anything, and we are creating the mask and adding it. So in mask, the things which are not blue will be turned into 0. So that there won't be any pixel in that position. While filtering out the mask, it will use the bitwise AND function, which means if there is a pixel in the main image and in the mask as well, then that would be considered. If there is a pixel missing in any one of them, that would be neglected. Is that clear? I hope that's clear. Okay. And I am show, as usual, we are just printing the original and the blue object image. So if I run that code here, in this original image, there is a blue car with some background. It's on a street. After masking out, all the other objects are gone, even the tires. In the blue object image, there won't be some imperfections, because if you look at this part, this is where the window comes. It is not actually blue. So it is so accurate, it's filtering out the necessary part. So this is how you filter out objects based on the mask function. Is there any doubts in this part? Okay.
Bro, can you repeat the logic once again?
Okay, now wait. As we all know, in the logical AND operation, if both the inputs are true, the output will be true, right? So, in the main image, that is blue car, this one. In this image, all the pixels are present, right? So, each and every pixel will contain the value of true. And after masking out, I have to deal a lot with the videos. So, how to deal with it? Now, we are going to see that. So, reading videos is not like reading images. It's somewhat complicated, but you will understand it once you see it. As usual, we are importing CV to cap. Cap is the capturing. It's a short form of capture. I just gave it as a variable name. CV2.video capture is the function of 0. 0 means your inbuilt camera. So video capture of 0, it will start capturing the video from your inbuilt camera. If you have secondary camera and you don't want your inbuilt camera, you have to give 1, then it will go to the secondary camera. And before we jump into this part, I want to ask you all that, what is a video?
Collection of frames.
Exactly. Video is a collection of frames. So we are running an infinite loop. You know what Walt Disney did? He collected a lot of images and spin the wheel at the highest speed, which looked like a video, which is what we are doing right now. This loop does the turning effect, and for each and every millisecond, the frame will be read and the frame will be displayed, and it would be looking like a video, which is what we are doing here right now. Read, comma, frame equal to cap.read. Cap is the captured value and dot read. If you read it, it will return 2 variables. The first one is if there is any pixel at all. If the entire camera is blank, if there is no camera in my laptop, then it will return false. If there is any camera, if the pixel are capturing, it will return true, which is why we are taking here if not read. That means if not true. For example, if return is there is no camera, then it will return false. If not of false is true, so then the function will execute error, failed to capture frame, because there is no camera. So in our case, we have a camera. CV2.im show of video display. It will display that single picture, and if you notice here, the wait key is 1. So for each millisecond, a new frame will be captured through the camera and will be displayed in the screen. And 0xFF. So what is this representation?
Hexadecimal.
Exactly. What does this mean? Okay, as you all are first and second years, you might not have familiar with this term, but this is the default value for keyboard reading. In OpenCV, we treat this as reading data from the keyboard. So while reading data from the keyboard, if 0xFF, that means the read data is equal to ORD of Q. ORD of Q will convert this Q into the ASCII value, and since this is hexadecimal, this hexadecimal value and the ASCII value, which is Q. That means if we press Q, then the loop will be broke. That means we don't want to see the video anymore. Then if we press Q, the video will be turned off. That means the loop will be broken and the computer, the camera will not read any more frames and the video will be cut off. Is that, do you guys get it? Why Q? You can keep any other variable. I just clicked Q because it's the first letter. I am a bit lazy. So yeah, let's run this code. Yeah, that's it. So for each second, it is reading from my camera screen, and frame by frame, it is displaying. I gave the window name as video display, and you can see the window name here, and that's that. And if I press Q without closing the program or without clicking the X button, the code will automatically break because of the loop. Do you guys understand it so far? Are you guys with me? Okay, fine. Okay, now that we know the how to capture videos, now that we know how to mask out a separate color from the video, from an image. If you can do it in an image, you can do it in the video as well. So how about we combine them? As I said, the same scenario, a criminal is on loose, he's explaining with a blue car. But blue car won't be an image, it will be a video. So that we have to mask out all the blue objects, so that the criminal will be caught if he's not surrounded with the blue cars. Unless he is surrounded with the blue cars, then the police are screwed. That's not our problem. Okay, let's start this code. First of all, let me run this, then explain. It would be more easy for me. Okay, so this cap is a green object, sorry, blue object. So it's squaring out the blue part and neglecting all the other part of this video. As we seen before, capture video function, we just now seen it. Lower blue and upper blue, you know what it is. And term crite, I will come back to this later. You will understand when I explain the median. So as usual, we are reading each frame, we are converting it to HSV like we did in this program. We are masking out and we are finding the contours as we did in the detect shapes. We detected shapes like triangle, square, and named the color. So we are finding the outline. So after masking out, this pen cap will be the only one which is in the image. So everything like this one. So just like the car in this image, the pen cap will be in the real-time object tracking. So in this code, the entire part will be blurred, will be turned into black, and the pen cap will be the only thing in the frame. And we are just taking the outline with the contour function, and we are taking the largest contour because, wait, let me turn on the video again. Yes, if you take this into the account, you can see there is a slight bit of blue in here, right? So this blue because in the frame there is only one object can be taken into account. So if since we have to take only one object, we have to maximize the chances by taking the largest one. That would help more. So we are taking the largest one, and we are selling the tracking window. The tracking window is the green color rectangle you just saw, ROI. ROI is the area of the interest area that we are seeing. You know, for our case, the interest area is just the blue color cap or whatever the blue object that I am holding. So hist hist is histogram. Histogram look like a graph, a straight line. If you all are you guys familiar with histogram, when I show the image, you guys will get it. Yeah, this is a histogram. So when I turn on the video, these kind of images will be going on in the back end, and it will look at the histogram, and it will take, since it is a straight line, it's 180. Of course, if we are taking this all the colors, we will be giving 360. And in this histogram, from ranges 0 to 180, there is no mask. Why? Because we already took the mask manually before. Here is the mask. So we don't need to do that again. That would be a waste of time. And CV2.normalize. This is a min-max normalization method, and alpha, beta are minimum and maximum values in our case. Min-max normalization, let me help you with a little analogy, then you will understand it better. Let's say you are having an apple shop. Okay, you have 10 apples. You have an objective that you have to make a transaction with the next customer. All right. So when you are meeting the next customer, if the customer is asking for 100 apples, but you only have 10, what would you do? Hello guys. Do you guys understood the analogy, right?
Yeah, no.
Yeah. You are selling apples, you have only 10 apples. What if I ask for 100 apples? Bro, it's not rocket science. Somebody answer, please. Two possibilities. Yeah. What are the possibilities, Bharat Vishnu? We will deny. But your objective is you have to make a transaction with the next customer. No, you can't order. Okay, let me make it simple. If I'm asking 100 apples, you can say, I have only 10 apples. If you want, you can take these 10. Right? So likewise, if I want no apples at all, what would you do? You will explain your situation. I have an objective. I have to definitely make a transaction with you. Then you would sell that at least one apple. Buy at least one apple. Okay. So that's what this min-max normalization does. If the value is too low, it will change that value into the minimum value. If the value is too high, then it will be changed to the maximum value. Do you guys understand this min-max normalization? Okay, good. And then return comma tracking window of mean shift algorithm. Mean shift algorithm is the tracking algorithm from the OpenCV function. It will have 3 column masked image and the tracking window, which is the green rectangle, and the termination criteria. Then first let me explain what is mean shift algorithm. Wait. Okay. When I'm tracking this, you can see the entire video, but what the computer sees is only within this green rectangle. Okay. First, it will take each and every pixel from this blue color pen cap and it will calculate the mean. So average amount of blue pixel in this area. Okay. So if I change it to here, it will take some time because it is calculating, okay, in this area, the average amount of blue pixel is very low, which is why you have to travel to this area. Okay, then it comes here. And just like that, it is checking 10 times. If for 10 times, not even one pixel is moved, then it will be terminated. Have you guys understood the concept? Termination criteria is term grid. For 10 iteration, if no pixel from the tracking window have moved, then the condition will be terminated. That would be the final value. So it will not change for 10 iteration. But in our case, if I close the camera, what will happen? For 10 iteration, there will be no blue. Then what would happen? There is no blue objects here. It is searching. You might see the little green dots in the screen. But if I close this, okay, it's still calculating some arm. Okay. So there is no blue objects for 10 cycle. In a loop, 10 cycle, by the time I finish this sentence, there might be even 20,000 cycles might have run. So why didn't it terminate? Because we are running in an infinite loop. In infinite loop, it won't terminate like that. So that's for the main shift function. We are tracking it. As Sajanya has explained before, we are tracking window X, Y, W, H. These are the starting coordinates of the green rectangle, width and height of a rectangle, and cv2.rectangle function will draw that rectangle. So without this function, there will be no rectangles at all. And this is the color, thickness, starting point, ending point. Is that clear?
Yeah, Anna.
Okay, fine. Done. Then we are showing the image as we seen before. Wait key 1. If we click Q, then it will close, release, destroy all windows, and that's it. We have completed the real-time object tracking, and along with the real-time object tracking, we have completed this session and today's and the 5-day summer camp. So thank you all for supporting. You all gave great feedbacks and great comments, and there were ups and downs in the session. The live stream was not working on the first day. There were ups and downs. So you all stood together and supported us. Without you guys, this might not be this much successful. Thank you all, and please keep us supporting. Do you guys have any feedbacks? Please say it in the meet. Yeah, Harish K.
Despite all the technical glitches, you guys have done very great job.
Thank you, Harish K. Okay, anyone else give some feedbacks? Just make it interactive. After today, we won't be meeting actually W's in the chat. Yeah, let's see some W's in the chat box. So yeah, after today, we won't be seeing anymore. So just don't be shy. Just give some feedbacks. Anyone from the audience? No, it's not like that. In this summer workshop, okay, let's see. We won't be meeting till college is open. Yeah, more or less orientation. That would be great. So yes, somebody just yeah, you all gave nice feedback.
Anna, I think Manimaran Anna has more feelings in it.
Yeah,
So can
I see
just
a lot of hearts. Okay, let's leave feedbacks. Do you guys have any doubts? Yeah, Gayatri, yes, thank you so much for the 5 days workshop. I have enjoyed learned new things. It was the latest skills. Thank you, Gayatri. Keep supporting us.
It's very
thank you
happy to
guys.
see
We
all
are
you
very
guys
happy to
supporting us.
see comments like this. But we will be more happy if you turn on your mic and say it. We will be more happy.
To be honest, I can't understand much, but this workshop gave a roadmap. Okay, yeah. And don't be like that. If the workshop is ended, you can't contact us. No, don't think like that. Even if you get any sort of doubts, even after reopening, even after years, if you have any doubts, you can backtrack and contact us. We will be answering. Yeah, on the poster you guys have in the group, of course.
You can see the member behind the robotics club. He'll be answering all your questions, or he'll be guiding us to the guys you want to talk about.
Exactly. Yeah. I just watched. Thank you. Thank you, Rajasugam. Yeah, you are the new member, but yeah, you gave a lot of support. You interacted much. Thank you for your support, and we expect the same kind of support when we do offline workshops in campus. Yeah. So regarding robots, regarding your field, or regarding your normal like elective selection, so any sort of doubts you can contact us. Yeah, we're just your seniors, nothing more. Hello. Oh, okay, okay. Thank you. Yes. Okay, guys, if you have any doubts or feedback, you can just unmute or put it in the chat box, or else we'll wind up the meet. Once again, thank you so much for your contribution. And please don't forget to
Important thing, if you have any doubt regarding OpenCV, you are free to talk to Kuberan Anna or any of the tutors who taught that part.
yeah, of course. And don't forget to fill the feedback form that would be taken account as an attendance. Most probably, you will receive your online certificate within 2 days by mail. Yeah. Okay, with everything said, we can wind up this session and we can wind up the 5 days summer camp. Thank you for your support. You may leave.
Thank you,
Any
guys.
doubt not related to session? I was interested, but this silently. No issues. If you're given in the feedback, if you're given your correct name in your feedback, then the certificate will come to that name and that mail ID. Yeah, professor want to say anonymous. Hey, don't worry if you. No worries, no worries. Hmm. Yeah.
Yeah, it's confirmed only, Harish. So there is gonna be a heist in the next recruitment, it seems.
Yeah.
Guys, we are very thrilled and we are eager to Get your guys to the team.